So now we've created our decision tree algorithm, we've had a look at it, we're going to have a look at how to use it. There's a couple of ways you can do this. We're going to create a new iris to start with. So we just have the sepal length and width. So make sure this is a two-dimensional array, so you have those two brackets or a list of lists. Let's have the sepal length as being 5 centimeters and sepal width as being 1 centimeter. And we'll load that in. So we can predict the type. So let's predict our type of our new iris. Let's give it a better name. Let's call it new iris. And we run the iris tree. Dot predict underscore probability of our new iris. So this is going to predict the probability of what type our iris is. So it's going to put the data through the decision tree, it's going to follow it through, it's going to work out which decision tree leaf it ends up in, and therefore which iris type. So we can have a look at our iris type, and it will give us, so it's new iris. Third time. There we go. And it tells us in terms of our three options. So we have three options in order: the setosa, the versicolor, and the virginica. So it's not these two, it's the middle one, so it's the versicolor. So you would then need to pop a little bit of code in there just to pull that out of there, and you can then swap that to the name of the iris if you want. So you can create a 3x1 Python list of the names, and then you can index into that, and that will pull out the name for you. The other thing we can do is we can put the measurements we've already got. So we have measurements that we created our decision tree from. We can test those, and this is going to work in the same way, but it will also allow us to get some kind of handle on how good our decision tree is, because if we feed the same data in that we created it from, it should do quite well. So if we do iris underscore tree dot predict, so this time we're not predicting the probability, we're predicting what it's going to be, the actual type. So if we just print that out, that will make more sense. So it actually spits out the value. So you could have done that here as well if you wanted, and that would have just printed out the value. Or you can do it where it tells you what it is in terms of a list of lists. So you can go through this and check whether there's 50 setosas, 50 versicolors, and 50 virginicas if you want, which if the answer was perfect, that is what it would be. But we can do this in a slightly different way, using an actual inbuilt algorithm to find out how good our decision tree answers are. So we can import something again from sklearn, and this time it's the metrics part. We're going to import an accuracy score and just execute that. There we go. So I'm going to print it out straight away. So I'm looking at accuracy score, open brackets, of my iris species compared to my prediction. So this here. And if I spelt iris with two I's. Okay, so actually, that's telling us that we're only 92% accurate, and we can spot them here actually, because these should all be virginicas, but we've got a versicolor there, a versicolor, there's a few versicolors just hanging around, and probably those two should be versicolors as well, so there should be 50 of each. Oh, there's another one. So if you look actually at the text, you can start to spot where some of the errors have crept in. So this tells us that our decision tree is not 100% accurate, because if it was, it would have done the data that it was trained on perfectly. And actually, that's probably slightly better, as we've hopefully avoided too much overtraining of our data. So there's a couple of ways there you can work out what you've got. You've got the probability of something, and then you can actually work out its value. And this gives you a feeling of how good your decision tree actually is. The next video, we're going to look at how to do that more rigorously with statistics, and we're going to have a look at the cross-validation score, which will tell us how good our decision tree is at predicting its type. I'll meet you there when you're ready.